Hello again. My name is Harvey Molino, and if you're joining us for the first time, shame on you. But I'll give you an update on what we are doing. I'm giving you little snapshots of what to expect when you attend a John M. Campbell G4 session. What we've talked about over the past couple of weeks, we've talked about phase envelopes, we've talked about hydrate formation temperature, and we've talked about energy changes. Today we're going to talk about separation. When you attend a G4 class, what you will be able to do at the end of this session is to discuss the basic principles of gas-liquid separation. You will be able to evaluate a two-phase separator. You will be able to state the general guidelines for vertical and horizontal separators, when you might expect to use a vertical separator or when you might expect to use a horizontal separator. You will recognize some of the common separator internals that we use in the industry, and to explain some common methods to handle liquid slugs which are constantly plaguing our facilities. Today, what I would like to do is focus just on the principles of evaluating a two-phase separator. The guiding principles of getting liquid out of vapor streams is based on droplet settling theory. And what we do is we develop procedures to allow you, a facilities engineer, to evaluate your operations in your plant. This is not a design course. This is a course that will enable you to understand what is happening in the facility and what actions you may have to take when you have upsets upstream or changes in conditions downstream. So we use approaches that will allow you to better understand the operation of a facility. The droplet settling theory is based on some assumptions, some of them being a perfectly spherical drop of a precise diameter, and the idea is that you want your droplet to fall out of the gas phase into the liquid phase. The point at which that droplet is suspended in space is when the drag force on the droplet is going to equal the gravitational force on the droplet. The basis behind one of the approaches we use to get the liquid mist out of the vapor is to make sure that your velocity, your terminal velocity of your gas is lower than the velocity required to keep that droplet suspended in space. That velocity is determined by this equation, which we develop in the G4 class of separation. It's a fairly simple equation that is also called the Suter-Brown equation. It shows that your maximum allowable gas velocity is equal to a sizing coefficient times the square root of the liquid density minus the gas density divided by the gas density. And we discuss during the G4 section how to determine the liquid density and how to determine the gas density. The sizing coefficient, K sub S, comes from experience. And once you have these parameters, you'll be able to figure out what the maximum gas velocity is to prevent the liquid mist from carrying over out into the outside of the separator. Another equation that you need for evaluation is a simple one to determine what your actual flow rate is. And we discussed this earlier during the during the session that your actual flow rate is equal to your mass flow rate divided by your gas density. Well, once you know your maximum velocity as shown in equation 1111, and you understand that your actual flow rate can be accomplished by equation 1113, you can put the two together and figure out what the area is of your separator. You know your maximum velocity from the first equation. You know what your actual flow rate is, so you can calculate the area. And we all remember that area of a vessel is equal to pi d squared over 4. We have to apply a correction factor, which is shown in F sub g, for horizontal vessels, because in a horizontal vessel, you are occupied by liquid, so your vapor phase, your vapor space is going to be reduced as your liquid level increases in a horizontal vessel. That's not the case in a vertical vessel. Having said all this, I have a question for you. How do you think you can use these correlations that are shown to evaluate a separator in your facility that is starting to give you some liquid carryover in the outlet? That's something we discuss in the G4 section, and we talk about that at length. The next time we meet, we will talk about heat exchangers. I'll see you at that time. Thank you.